Oh, yeah.
Okay, I think we're ready to get started. So, hello, everyone. Thank you all so much for coming out this afternoon to enjoy the second to last event of GIS Week, the Geospatial Forum. The last event will be happy hour at Raleigh Brewing Company starting anytime after this forum. Just head on over. It'll be a fun, informal event and a good way to celebrate the end of GIS Week. Now, before we move on to the official introduction, I just want to give some appreciation for the folks that made GIS Week happen. So a lot of people, and I'm not going to say everyone, but I'll just, I figure we can give them all a round of applause. So first of all, oh yeah. We have the graduate, student, and then there's an S organization, GSSO, yes, and the co-presidents, Margaret and Andrew, put a lot of work into the GIS Week events this week. Rachel and Lois made a lot of the logistics happen. John Vogler, Felipe, making this morning's workshop, forum, all of that come together. And of course, Director of CGA, Ross, for making CGA happen, and by virtue, GIS Week. So one more round of applause. And of course, you can also give yourselves a big pat on the back for showing up to all the events this week, supporting GIS Week, and making it a great turnout. So thank you all for that. Okay, so getting into the Geospatial Forum. Today we are welcoming Dr. Wu as our Geospatial Forum speaker, who is an associate professor in the Department of Geography and Sustainability at the University of Tennessee, Knoxville. He's a specialist in geospatial data science and open source software with a focus on big geospatial data and cloud computing to study environmental changes. He's an associate editor of not one, but two journals, including Wetlands and the International Journal of Applied Earth Observation and Geoinformation. He has developed several open source softwares, including GE Map and Leaflet. Both of these softwares are open access and make processing and visualizing geospatial data much easier and much faster, as was very much demonstrated this morning at the workshop. In addition to these softwares, he has also done a huge service to the geospatial community by investing time in creating educational materials, including videos and tutorials. If you've missed this morning's events, never fear, you can access many tutorials on the website gemap.org. So I encourage you all to check that out. So without any further ado, Dr. Wu, thank you so much for visiting NC State and joining us, and let's give him a warm welcome.
Thank you, Rebecca, for the introduction, and thank you for the invitation. Very honored to be here to present the workshop this morning, and also the forum. And so the title is, oh, by the way, I want to acknowledge the very well organized and also the workshop that they have done to make it easier for me to teach, so that we kind of spend this time on the debugging and also setting up. So thank you guys for doing an excellent job on that. And so my title is Spatially Empower the Geospatial Journey of My Career. And so this is not a traditional resource talk. This is my first time talking about something like this, how I started geospatial, how I ended up in the US, and what I'm doing right now, and how I think how the geospatial is going. So it's not a resource talk, not like in-depth topic or something. It's more like a general kind of the journey, like trying to share with you. So hopefully, if some of you are trying to follow a similar path in academia or industry, maybe we can discuss and give you maybe some insight how I'm doing it and what I'm doing, something like that. So originally, so it's only like half an hour, including presentation and Q&A. Looks like we have longer time, but I don't have a lot of slides, so I'm just going to quickly go through, and then based on the 3 prompts that I was given, and then I try to answer those questions and show you some of the mostly images that I've been going through the last couple of years. So there are 3 prompts. The first one is how has your career trajectory led you to using a geospatial perspective. So for all the 3 prompts, I have a short answer, and then I will elaborate it a bit how in the long version. So you might guess what's my answer? By accident. So I've never chose GIS by myself or geospatial. It's kind of like a long story. So first, I've never talked about actually my background, where I come from, and this is the first time I'm talking something like personal. So in showing here, I actually came from a very rural area in southern China. So you can see where it is. It's next to the South China Sea. So it's called Guangdong Province. It's a very rural town next close to the ocean. So you can see what it looks like here on the ground. And that building actually in the center is my parents where they live nowadays. So here all the farmlands, something like that. So I grew up in a very rural, very poor family actually. So I have 8 siblings. I'm not sure if any Chinese here, they cannot understand why you have 8 siblings. Usually we were single family policy, but in the rural area, there's no education, there's no actually, my parents do not have a job. There's a farmer growing the farm, and then you need the labor, and then, so we have a lot of siblings actually in that region. Unlike in the big cities, you have a one-child policy. If you have more, you want to take away your job, tear down your house. In the rural area, nobody really enforce that policy. So that's when we have a huge family, and I was the only one that actually went to college. All my siblings end up finished elementary, or not even finished elementary, and then went to a big city just to make a living. So, and it was very challenging. My parents, we didn't have actually like came from a rich family that you can get education quality. It was so difficult, and so we have to work in the farm like pretty much all day long. We not school weekends. Unlike here, like for fun, you go to the farm, but it's all labor. So unlike in here that you have machine you can do, we didn't have that. It's all labor. You grow like rice. So here I think I'll show you like this is what it looks like. This is the photo I took when I went back in 2017. So my parents actually are still doing that. And what's this? You recognize? Rice. Rice. It's a rice before you peel off the shell. This is original rice that we grow. And that's me like when I was like elementary school. So I was doing that before I went to high school. And this is basically my life is and also you can see all the like banana trees, like, and this is in front of the building. So you can see it's very underdeveloped. It's very poor. And at the time, I think in 2003, went to college, I was one of the maybe 5 students actually went to college. So I'm the first generation college student. And this is what it looks like the farm and also bananas. So when in the tropical area, we have hurricane every year, kind of like similar to Florida, the latitude. And this is what it looks like after hurricanes. You can see all the trees falling down. So it's very rough. I might have a very rough childhood that we have to support the family, do the farm work, and then we really hate these hurricanes because it destroys everything and rice and other stuff. So you have to actually to dry those, like for example, harvest the rice, and then you need to dry them out manually. Like just what I'm showing you here looks like this. There's no machine, there's no nothing. And you need to bring those back to you, like whatever. So I hate doing the farm work, and I don't want to be a farmer. My parents said, my father, if you don't like it, you just study, go to school, and then to change your life. So that's what I did, is try hard to go to school, and then try to avoid doing the farm work. And I'm not sure how many of you are familiar with the education system in China. It's very different here, that you enjoy the freedom, can choose the major that you want. We did not, okay, we did not submit recommendation data and then you can get admitted. It's all based on a single entrance exam with multiple like courses, basically discipline. If you do well, you get to choose what you want to study. If you don't do well, you don't even get admitted to a school. So not everyone can go to school. And it's not everyone can choose the major that you like. So in 2003, I took the like college entrance exam. And so in China, when we took the exam, in the past, you need to choose your major first before you take the exam, okay? So my parents wanted me to like become a medical doctor because it's a well-respected profession in China. He also make a lot of money. And my parents like him to see the doctor. So I actually chose went to medical school. So it's time, okay, I want to go to medical school. I want to do like, medicine or whatever. But my score was not high enough. So I actually did not end up studying medical school because it was very, in the university very top in South China. So only like very top students can get it. So I not high enough, I didn't have a choice. So when you sign up for this major, there is a checkbox on your application. That, do you want to be assigned a major? If you check that, you can go to this top university, but you are studying a major that they assign you to study. If you don't choose the option, you can go to a second option, you can go to a lower tier university, you can study the major you want. Probably you cannot imagine, like, only people coming from China, we understand that. So I actually checked that box. And this went up by doing GIS because I was doing like chemistry, other stuff. I was selecting like atmospheric science or something. And then at the time, they have some GIS. It was just go study in China 2003. Nobody know what it is. So even my high school teacher so is going to like dig the mine and then find some gold in the mine or whatever. So we had no idea what GIS it is. And that's where I went to college in Qiusheng University, and then did my undergraduate major in 2003 to well. So it's like by accident. I didn't want it to, but I was assigned, but I end up loving it. So then I'm staying in this major. So this is the School of Geography and Planning, and then so during my undergraduate, I learned like Arc-Info. How many of you have used Arc-Info? Okay, they represented were older generation. Okay, so this is in the early days when I was doing undergraduate, 2003 to 2005. I learned this. We have ArcMap like 8.1, 7 point something. So in the old days, we learned this all like command line. And then, so in 2005, like Google's released the Google Earth. But initially it was called Keyhole. It's a company like established in 2001 and then in 2005. So I was like sophomore in college. And then when this was released, so at the time, Google is still accessible in China. It's not blocked. But now you cannot access any Google stuff in China anymore. So this is when I originally like look at Google. This is amazing. You can look at the Earth. You can see anywhere you like. You can see the images seamlessly. I was amazed and I was addicted to this. So I've been staying there all the time. So I love looking at satellite images and love like doing some analysis, get some insights. So this is during my undergraduate, and then I finished my major. So it's called Geographic Information System. In 2007, I finished it. This is my whole class. And so we have, I think, 28 students in this GIS major. Guess how many students actually chose GIS like as the major when they sign up for the application? How many? One. 1 out of 28. So nobody actually chose to study GIS. But we ended up everyone like, but now probably only couple, 2 to 3 stay in academia, mostly in the industry or government, but not many people actually do GIS after they graduate. So it's kind of very sad that we spend so much time doing this, but at the end, you're doing something totally irrelevant. So I'm probably the only one that really stay in this track doing the academia and doing GIS. So long story short, is by accident. I didn't choose to do GIS, but I ended up loving it because I saw those technology and GIS and Google was essentially Google's make GIS get into the hands of everyone. Although they don't claim it's GIS, but it's the same technology. And after that, I kind of stay in the university doing like master degree. And then so my advisor have hosted a conference in what's they call geoinformatics. So they have some faculty from overseas attended the conference. And so I met my PhD advisor at that conference because he was a good friend of my master advisor in China. So I picked him up at the airport and talk, and then end up that he has some funny project that needs PhD student. And at the time, I have never imagined that would come to the US. I was just graduate, find a job, and then stay home and then in China. But ended up that at the time when I was finishing my master, undergraduate, I had a girlfriend, and the girlfriend came to the US first, went to Texas A&M, and then so this PhD advisor happened to be the same university. So and then they talked to my ex-girlfriend and say, "Oh, come together, let's go." And then you need to take a COBOL score, GIA, went through all the stuff, and then so we broke up before we everything's amazing, but we broke up because she found a better one. And then I was debating, should I come or should I just quit? But my PhD advisor used to come like, I think I didn't tell him that I came to the US because of my ex-girlfriend, but I just said, oh, this the project I'm really interested in. But eventually I went to the department and in the same department with my ex-girlfriend. It's like awkward. But luckily, my advisor left Texas A&M for University of Cincinnati after half a year. So then he took me with him. And that's why I ended up like in Cincinnati for half a year. So kind of funny story. I never intended to study GIS, but I ended up doing. I never intended to come to the US, but it's kind of but in Texas A&M, I was doing like hurricane risk, coastal change analysis, did a lot of field work, but it's only like half one semester. And then I left for Cincinnati, get my master and PhD over there. So those in the center, which is my advisors, my advisor, 2 PhD advisor. So with him, and that's what I actually did in my PhD. And this is a paper that I did for the master's thesis. It's doing coastal change analysis using LiDAR and AOA. It was published in 2016. So I finished my master's degree in 2011. So it's a very late, but I got it published anyways. I actually presented like at the AAG, I think in 2010. So the first year after arriving in the US, I actually got the, I think, first place in the AAG competition. But it took me 5 years to actually eventually publish it. And my advisor, you need to publish it, but after I did my PhD, I is doing all other stuff, and it's just have some challenges getting this one, but I said, I'm gonna get that, and then eventually it's done. But my PhD mostly doing, like initially doing soil moisture mapping related with drought. And so my PhD advisor did not really have a lot of expertise in that area. It's just that that's like something very promising and also funding opportunity. And I was doing all the passive remote sensing and SAR and other stuff. But I was not that smart, so it took me a while actually to be able to figure out. But it was too late. I spent 3 years doing like soil moisture, and I could not really publish anything. I almost quit. So I was like so frustrated that I cannot like really, because there are a lot of things you need to learn by yourself, otherwise I cannot really help you that much. And so during my last year, I worked for as a contractor for the US EPA. They have some mapping and doing LiDAR. And I really like the high resolution. Moisture is like kilometer in the pixel, and then the uncertainty is really high. I kind of really hate it. And then I go into this one. I actually already finished my competency exam and everything on top of soil moisture. But last year I go into this one. I get 2 papers out in the last year, and then just graduate. And the department was okay. Like although the topic all really changed, but I mean the techniques are kind of similar. So this is like in 2014 was my first also publications with my supervisor at the EPA and also my PhD advisor. And public remote sensing, at the time remote sensing was still like, in the early days we were very respected compared to right now, like a lot of negative comments about those journals. But anyway, I go in there, and then this is a great thing, like using LiDAR to map whirlpools. I go in there, and then later on I improve the algorithm to develop something called contour tree. Basically, on the left side shows you like a DM. You can, if you do hydrology, usually you feel the DM, right? If you're in Taiwan, and you end up with those like huge depressions. But actually, in reality, most of them are not fully filled because water level is not that high, and there is usually a hierarchy actually within there. Kind of like I trying to detect the wetlands. It's not going to like a huge wetland. It's going to smaller one inside. So the algorithm actually detect the hierarchy. So this one is published in IGCS. And that's it. So I finished my PhD with these 2 papers, and then I applied for a job, and I was lucky to go into Binghamton University. So I mean, nowadays, still, the market is so more competitive. I don't think you can get a job like just 2 first out publications as a tenure track. So at the time, it was not very competitive. So this is basically how I end up like in academia, is because by accident of doing all kind of stuff. And yeah, so we have 10 minutes, so I'm going to quickly move on to the second one. Second one is what role do geospatial approaches play in what you do? So my short answer is, yeah, a significant role. Everything I'm doing is geospatial. So it's like, because my undergraduate major is geospatial, my master PhD is all in geography. So I'm still doing geospatial. I continue the work that I did in my PhD. So I continue to do wetland mapping, porosity portal, so integrating LiDAR and also analyze the inundation dynamics. So this one was also in 16, published in wetlands and also doing hydrologic connectivity, trying to figure out how the water body connect with each other, upstream, downstream. And this is very much related to, for example, some species movement and also ecology and other stuff. I'm not an ecologist, I'm just a guy doing this based on the EM topography to figure out how the water moves on the landscape. And also all the tools is all available. You can see kind of hierarchy in here. So basically water feedback. You know exactly which one is going to merge with which one. You know how the water is going to move based on the topography. So you can basically focus on surface water, but you can also do underground water. And this one was published. And then later on, I continue to improve because I know the algorithm is not very efficient. So I kind of developed another one called a level set algorithm. It's also to kind of simulate how the shape changes when the water move up, water level move up, or it's drying up. So you can think about like you have a big depressions. There might be many smaller inside. So how do you know how many in there? How do you know how long does it take to fill the depression? How much water do you need? When it's going to happen? And if it happens, which one is going to connect to which one? So basically you have the whole network within there. So I improve algorithm, improve the efficiency by like 50 times. And all raster base is very efficient, also published. And then, so in 2018, 2019, I started to learn like Google sending cloud computing. So at the time I realized, okay, you can not only focus on a lot small area, you can do like national scale, large scale, and then use tons of data. So this is where I got started with Google sending and cloud computing. And this is the paper published in a remote sensing environment, mapping like surface water dynamics and small water body, especially using the USDA net imaging, 1 meter resolution. So you can clearly see, for example, automatic, so you see the boundary. Those are all automatic during Google setting. And this one is using a laser, for example. You can see the boundary and also missing all the smaller water bodies. Large water body usually are pretty, you can use like laser, sentinel, usually fine. But smaller one, they're not captured because it's less than 1 pixel. So it's very challenging for those, but the algorithm are automatic, and you can also compare, for example, with the NWI, Nation Wetland Inventory. This is usually beginning in the area was 1980s. So it has been like 4 decades. The data, probably you know, like you know exactly what I'm talking about because from a Fish and Wildlife Service. But this is what we, but certainly now they're trying to update, but still it's a very manual process. So I develop algorithm, and you can see also multiple time periods. So basically the top row, that one is automation without human intervention. And you can get the boundary pretty quickly. You can also get the inundation dynamic, how many times that pixel is inundated by water. And it's very powerful. And I really like the cloud computing, the approach. And then, so that's why I kind of developed the packages to help me with my data processing, because I need to process a large amount of data. And I really like Python. And I was also teaching my students how to learn Google sending. So when I got started in 2017, 2018, for those of you that will go study at the time, you know this whole JavaScript. There's pretty much zero Python stuff on their website. And I learned JavaScript. I had a hard time get used to it with all the web design and stuff. Went to Python, and Python basically, you can only do computation. There's no really visualization. You cannot actually see the image interactively after you finish the computation. Just like something I'm showing on here, right? You see the imaging. But you can print out thumbnail. You cannot zoom in and zoom out. It's very frustrating. So I went back to JavaScript, could not get used to it, and then went to Python again. So at the time, there's a lot of new open source packages, Folium, IPy, and I figured out a way, you can actually load the data into the map and you can do it interactively, just like you're seeing Google Maps or something like that. And then I figured, I need to do some interactive functionality. You want to click on the map, you want to get the coordinates, you want to see the pixel value, you want to do all kinds of stuff. So I learned IPy widget, Jupyter Lab, basically the whole Jupyter ecosystem. So it took me a while to get used to know. But it works out pretty well. I was able to actually develop those interface and teach my students how to do that. And this is basically when I got started right after the pandemic, because everything moved online after 2 months. I think in March 2020. So at that time I was at night, didn't have much to do. I was doing coding, and then create the new feature, make it easier for students to use, and then I teach the next day. So I release it at night, and it's like basically a hectic schedule. But eventually the community like it, and there are a lot of people asking new features and then reporting back. So, and then the rest is history. So I release a new version pretty much every week, add some new features, and then release, and then teach students how to use it. And by now, it's like used by 1,000 more than 1,000 project, a lot of contributors. And so GMAP has been officially adopted by Google. They really announced it in the last last month in Google. So now it's, if you want to learn Google Sensing Cloud Computing, just like what I covered this morning, then GMAP probably is the one that you do. So it becomes more stable because now Google engineers, they have support. I've worked with them weekly, just trying to help organize and make it easier for them to maintain. So GMAP now is like separate into the core and the extra. So the core is like co-maintained, developed by Google. And then the extra is like I develop, the community develop, but yeah, mostly it's me. Because the source code becomes complicated. Most people just report the bugs, but welcome contributions. If you know how to do coding, you're welcome to contribute. You will be showing up in here as a contributor. So it been used like hundreds, thousands, and even I think I published a paper just describing the GMAP plus 1 to 2 pages. You get a lot more citation than my traditional journal publications because a lot of people use it for all kind of applications. So, so this is kind of the kind of some benefit of using creation tools and platform that other people can use. And you can do the same thing. So you can, whatever research you're doing, you try to think about how other people can use the stuff. How do you make something generalized? How do you conceptualize and make it usable across platform? Windows, Linux, Mac, whatever, and then different environment. Then more people can use the stuff, and then we will come to contribute. So if it's something useful, you can try it out. So and because I published so many notebooks, right now I think it's 139. So each notebook introduced like a feature, new feature that I developed. And last year, the publisher called Locate Press reached out to me and said, "Oh, it looks like the community likes Earth Engine. Can you write a book about that?" I said, "Yeah, I have never written a book before, but I'm not very confident that I can write it." But he said, "Already have all this. You just reorganize it, maybe like more like systematic instructions." Okay, I can try. So this is the most during the pandemic. I think it took me a year, a half to actually do that. Mostly from 9 p.m. to 1 a.m. just to organize stuff and then more. But eventually it was published like in July this year. But all the source code is open access. You can check out the link, book.gmail.com. You don't need to buy it. You just can click the notebook, you can run it, you can test it out. So all the source code are, so everything I'm doing is reproducible. If I produce something, you can do exactly the same. And I provide the notebook for you to do, and you can just customize it into whatever you want. So this is like mostly the Google Sensing, and the last 2 years I kind of transitioned to more like open source, like not just Google Sensing Cloud Computing, but you can. I think the reason is because GMAP was quite popular, and some people use it, but they don't want to use Google stuff. They don't want to use Google, but they want the interactive functionality of the map. So I kind of took out all the functionality that do not require Google Sensing, and then take it as a new package called GMAP. So this one was like in 2021, so a year after GMAP, and then so this one you can use in any Jupyter environment. You can use it with AWS or Microsoft any computer, locally or in the cloud, and kind of very similar to GMAP. But the downside is that for the computation, you need to figure out the computation. Right now, this is mostly for computation, but GMAP, the computation is handled by Google Sensing. But this one, you need to basically, it takes up more time to do that, but it's free, it's open access, you don't need to worry about the licensing. With GMAP, if you use for commercial, you need to pay the commercial to Google, not to me. I don't make any money out of those open source. It's all free open access. And anyone can use it. So this one actually is adopted by Microsoft. If you use Microsoft Planet Computer, GMAP is pre-installed there because it can help you visualize all the data that they have. Kind of like what I'm doing. The analysis, like I make it easy for you to watch a movie. That's it. So in the past, you have a huge data movie database. You have to have a DVD-ROM. You have to have all kinds of stuff to have a computer to watch. Now you can watch on your cell phone. You can use a laptop. You can watch it anywhere, as long as the internet. So this is kind of a similar way. It's transition from the old computing to the cloud computing. And I develop those interfaces that helps you easier to view. That's it. So it's not really groundbreaking. It's just like makes it easy to use. That's it. So you can do the same thing. I mean, if I can do it, you can do it as well. So this is the lead map. You can see here also used by 1,000 projects on GitHub. And so those are the two projects that I do. But the last couple of years, I have a lot more interest. So I also do a lot more projects. So these are all the projects that I create and maintain. And it's called Open Geospatial Solutions. Originally, those projects are under my personal account. And then some companies, they want to use it. They are a little bit worried that I might be gone someday. Nobody is going to, it'll be screwed because nobody have access to my account if it's gone, if I'm gone. So then I say, okay, that's fine. I can create like organization. I move my project out. So this is basically end up where it is. I move some of the project from my personal account to this one, and then have some other team members. So if one day I'm no longer exist, people can still continue and develop. So it's more sustainable. And then especially for companies that want to use for commercial, you can do it. But I cover Gmap and LeadMap, but there are a whole lot more other in there. So of course, a real contribution if you want, you are capable, feel free to look at the source code. So what I'm doing is basically mostly packages, but also a data catalog and also web apps. So think about here, if you want to watch a movie, you need to have the movie, right? And you also need to have the hardware software to watch the movie. So this looks like the data catalog. I help you organize, find out where those movies come from. So if you want to watch a movie, it certainly doesn't really matter whether the movie is like on AWS or Google Cloud. Your purpose is just watch a movie. So the data catalog basically help you centralize, basically aggregate all the data sources. So all you need to do is like pointing to this one, I want to watch a movie, and get the data set. And then you can use the packages to visualize, to analyze the data. And the lastly is the web app, basically help you turn your application into a web interface that anyone can access. So they don't have to know how to do coding. They don't need to set up their server. It's all free. So everything here doesn't cost you anything. If you want to learn it, all you need is some patience and time. There's nothing involved that you need to pay anything. But you can make something that's really used by a lot of people using this open source technology. So I encourage you to try it out. It's on open.jshub.org. All this is used by a lot of people around the globe. And so that's pretty much like how geospatial play a role in my work is, yeah, it's a significant role. It's every day. Everything I'm doing is mostly just coding, help people how to utilize this tool and makes it easy for them to use. And mostly it's just to help myself. But in the meantime, if you help other people, that's great, right? So, and my time is where utilized rather than I'm doing something that's only I'm reading my paper, my student read my paper, but it's like a tool being used by a lot of people. So in the meantime, I create tutorial videos. I also record all my teaching is all online, and so everyone can learn from those cloud computing resources for free without having to pay anything. Okay. And last one, what's the future of geospatial analytics in your view? This is just my personal opinion. Big data, cloud computing, and geo AI. I think this kind of a tools to train just like ChatGPT. Right now, everyone probably have tried out or not. But the reason why I'm saying this is I'm going to give you an analysis here. Laser data. If you have two remote sensing, most likely you have access to some laser data. So right now I have Landsat 9, right? One image, roughly 1 gigabyte. Okay. Landsat next is going to launch in 2030, in 7 years. And the spectral resolution is going to increase from 30 meter to 10 meter. And then the spectral band from 11 to 26. So think about how many times the file size increase. It's more than 20. So right now it's 1 gigabyte. In 7 years, it's 20 gigabyte. So imagine when Landsat next release the data, how you're going to access and process the data. And if you're trying to download the data, good luck. Okay, it's going to take you hours to download 20 gigabyte. Even if you can download, you need the storage. Or even if you have a storage, you need the compute. Where do you have if you want to process the data with 20 gigabyte, you probably need to have at least like several times of the file size in order to be able to load into the memory, right? So imagine in 7 years, you maybe need to have a laptop with 80 gigabyte of RAM to handle that. And I'm sure the hardware is going to improve, but if you went back to like right now, 16 gigabyte, what was that 7 years ago? It's not going to be increased that much. So I can guarantee you. And if you're still doing those computing locally, and if you're doing large area, good luck. Okay, when the data released, everyone's like doing this, doing that, using cloud computing. You're still downloading. You cannot really do anything, even if you download. So I want you to keep it in mind. If you really want to like utilize those data set, make sure they have some capability to process this kind of data. And this is just one example, just Landsat, but it can be Sentinel, next generation. It can be plenty imagery. They have daily, they have 3-5 meter. The volume is going to increase. So big data is going to be certainly here to stay, and you will need to compute. But most of the data will be in the cloud. Not many people have the storage to actually store the data. So just to keep it in mind, and then computing, right? So in the old days, what's the DVD? Buy the DVD. Take you a couple of days to get the DVD, and then maybe it's broken, maybe Amazon sent the wrong DVD. I mean, in the old days, then you send it back and then replace, and then yeah, it's going to take you a week or two to get set up, and then you need to have a DVD-ROM and then the hardware. Right? Nowadays, it's mostly just streaming services, and so in the geospatial domain, it's kind of like this. Right? We are in the transition from desktop computing to cloud computing, and those are three like major providers: Google Engine, Planet Computer, and AWS. So Google Engine is like right now it's a leader and in this area. But I think the company doesn't matter. It's more like your mindset, how to transition from here to cloud. You can have your private cloud, you can have your own data set, it doesn't really matter, but you need to prepare with this like increased volume in data. How do you prepare yourself that you'll be able to handle this kind of large data set in 7 years, in 10 years, in the next decade? It certainly it won't be feasible. If you want to do like global scale study dealing with 1 meter resolution imagery doing every day, this computing cannot handle it. So this one to keep in mind. And in terms of like cloud, what kind of things you can do? There's a so-called cloud native or cloud optimized geospatial data format. And it's a nice website, you can try it out. There are things in there. So if you right now, if you look at this one web page, you're not familiar with any of those, then probably now is a good time maybe to get familiar. Otherwise, in a couple of years, everyone is watching movies in Netflix. You are still trying to download a movie as an MP4 and then trying to watch a movie. It's going to be not very efficient. So, but this is still like actively developing. So there are a lot of new things. But try to maybe learn something out of this like cloud format and then see how to analyze. You don't have to know everything because nowadays, with those internet, there are a lot of examples. And ChatGPT is your best friend. You can pretty much learn anything. Just time the question, you can give it some example, you can make changes, and then help you learn really faster. In the old days, it's funny, you can search the internet and then just scroll through, spend so much time. But now it's so much easier. So you utilize those two and to learn some of these things that you can do in the cloud. And lastly, I'm going to quickly show you some examples. So this is more like doing geospatial analytics, geo AI. So I'm going to show you like what's the status right now, what's missing. So here, this is like Morocco earthquake, right? We have a lot of images released by MaxR, so you can see the destruction of those disasters. But the problem is that after this kind of earthquake happens, it takes a couple of days for people to, even for MaxR to release the data. And they only release the data, they don't release like how many buildings are destroyed, where the building footprint, and how do we quickly get some insight. So this one kind of is still lagging behind the data, the compute, and also the model, how to quickly extract information. You want to take 3 more years before you can get into that. But these are some of the web that are created to help users. At least you can see the images, see how the landscape is changing. So this is earthquake, but there's also, for example, flooding, for example. So you can see the flooding in Libya, right? So MaxR release the data. They don't even have an interface for you to visualize the data. So kind of use the data catalog and makes it easy for you to actually compare. So anyone can use. So those people on the ground, they can figure out like what's the damaged area. But again, there's no analytics. I don't know how many buildings are destroyed. I only see like visually, yeah, it's destroyed, but yeah, how much? Nobody can really answer. So it usually takes a couple of days or weeks before people can analyze, build some model, do the detection. And especially for underdeveloped area, the building are not available, for example, infrastructure not available on OpenStreetMap. It's not available anywhere. It's just imagery. So how do you turn something from this imagery into some insights and figure out like where should we prioritize resources to help the disaster recovery? So I'm hoping in the next few years we have more development on this like AI and geo AI and also this cloud computing to make it easier for this kind of disaster response. And this is another one, like I use the segment ANSI model to do segmentation of the images automatically. So they can quickly, for example, extract the building, and then can roughly figure out like how many buildings are still there, how many were destroyed, and then you can like extract the polygon, you can see the size, something like that. But this is like all automated. It's certainly not going to be perfect, right? And nothing is going to be perfect if you're doing automatic way and for a large area. So, but it's also very promising. But again, who is going to do it? Where do you have the GPU? Where the computing resources coming from? And right now we're solely relying on big tech. Like when this happened, people are begging like, because Google released the open building data set, Microsoft also have like open building data set, but they don't have the data for this area. People are begging like, could you please run the analysis, get the data for this area? We need it for our disaster management. Yeah, you are at the mercy of those, but it would be nice if citizens, we can do it on our own and we can run it anywhere. Anyone can do it, anyone can contribute. But for now, we're still more like on the data collection, data visualization. In terms of analytics, geospatial analytics, we are still behind. But it will be cool in the next decade, we have data available and then everyone can go online, they can run analysis, everyone focus on a small area and then put all the things together. Anyway, so also for example, buildings, like in terms of buildings, so this is another package that I created based on segment anything model. So you can like interactively extract the building, create a couple points. If it's not perfect, you can add some background points and then you can extract the building automatically using the foundation model rather than you have to train the model on your own. And it's all free and open source. It's called segment geospatial. So if you want, you can try it out. And you can extract the building footprint, rectangularize the building footprint. And I believe the last one I show you is here, like more like using text prompt. So give an image, just give me the buildings. I just have like buildings in the text prompt, you extract the buildings. Of course, like I said, it's not perfect. It's not going to like perfect result, but you can make some changes using customize the parameter. Again, there's no training or anything involved. It's just doing automatic. So for example, I want a tree. It's not perfect. You adjust parameter. It looks pretty decent. It's automatic. It's in real time. So I don't actually need to like do the supervised classification or train the model. It's pretty cool. And these are utilizing those foundation model that people develop. But there's the geospatial problems are so diverse. There's no single foundation model that can fit all the user cases. Unlike ChatGPT, you can dump images or text. You will give it some response, but geospatial is like a lot more complicated than those large language models. But yeah, I see the potential they can combine some of these things together to do some geoanalytics work that makes it easy for other people to utilize. Yeah, that's all I want to share with you. I hope it's useful. You see some potential that you can utilize also open source, but I'm happy to answer any questions that you may have. It took long. I saw I could finish in half an hour, but looks like it's yes.
You were talking about how like we're about to get the Lancet and that's gonna increase the size of the problem and whatnot. With more technology and the need to go cloud-based, there are also a couple companies that are starting to release satellites as well, and they're not as open source. Do you think with cloud-based coming out or us needing to do that, that they'll be more easily accessible, or do you think the price to even start analyzing that data will just increase and increase till it's only a few people that can actually utilize it?
Yeah, good question. So this one, I mean, based on right now the current landscape of those satellite data, so the government right now, for example, US here is mostly the USGS, Lancet, and NASA, those like high resolution data. But in terms of really high, is like, for example, MaxR planning like sub-meter resolution. But the nice thing is like governments, although they don't have the ability to develop those, but they're working with those companies. They have some programs. So if you get some funding from NASA, NSF, you can actually access to some of those data sets. But certainly, it's not for everyone. Eventually, there's no free lunch in the world. It's like, if anything is free, you think about how long it's going to last, who is going to pay the bill. And those things take time to develop and research and development. And somehow you need to have funding for that. But I certainly understand if you're really doing good work, you should be rewarded. So, but for those profit companies, for example, MaxR, they have high resolution, but they also do some nice work is release some open data for major natural disasters. So for example, the one show you earthquake, flooding, they release that, but they don't process the data. It's up to the community or who has the computing power to release. And especially in some like complicated situation, they have the data, but they just cannot release. For example, the war in Gaza, because of all kind of political issues, you don't have access to those data. So you still rely on Landsat and those cost resolution. But I think it's the overall trend is like we are getting more and more data. The resolution become higher and higher. The spectral band is going to getting more and more, and the temporal frequency you're getting daily, weekly. So the volume basically is continuing to increase. But the computing power is catching up, but is nowhere close to right now the data storage and the volume that's being produced. So certainly I think we need more research and development on that end to help them. But yeah, but I don't envision that everyone can process like tons of data for free for any long for forever. Somebody has to pay. So right now, I mean, Google, Microsoft, they all have some of those paying. The reason because they have some other programs to subsidize those free ones. But yeah, anything is free, keep it in mind, it's not free forever. Someone has to pay it. But at least right now we have enough computing resources that's free that we can utilize. So everything I'm showing there is all free, I can still use it. If one day it's not free anymore, yeah, we come up with some other alternative. I'm sure people will come up with alternative. It might not be as good as those like pay one, but you cannot stop the chain of, it can stop the wheel of like geospatial and cloud computing and big data. Yes?
So you talked about the earlier version of ARC that I used to program in Lisp using the ARC modeling language. It was called AML. And then the Keyhole software, when it first came out, I worked at EPA, and then it was revolutionary. We started using it, and soon after that, Google bought it. But overall, you know, last 20, 30 years, the GIS has been very compartmentalized a lot of times for the environmental science, and it's been expanding some. And with the Google Maps and Google Earth, it kind of became ubiquitous, right? And daily, average Joe learned about what GIS, not maybe what GIS is, but how to use it and how they can actually make use of it. But looking at this trajectory, where do you think is the next thing? Like in average Joe's life, as a ubiquitous tool, how the GIS is going to be part of our lives, you think?
Yeah, I think it's already in our, I mean, GIS is in our daily life, in everyone's daily life. If you have a phone, it's in your app, they're checking your location, but they just don't tell you it's geospatial analytics. All the tech companies, Google, Facebook, Microsoft, they're all checking your location, Uber, Facebook, whatever. But I think in overall trend, if you see, take the Google Earth as example, right? From 2005, the interface was, nowadays we see is quite ugly. But now you can see the changes from Google Earth Pro, and then transition to the cloud. Now you can actually see everything just using the cloud. So you can see the movement from there. Basically makes it easier and easier to use. And certainly I think it's a good thing for geospatial, because now the general public know like those images, those satellite, those apps, although they might not know it's called geospatial. But when you like talk to people, oh, what do you do? I say, I do geospatial. What is geospatial? I say, oh, do you view a Google Earth, Google Map? Yeah, that's geospatial. Okay, that's cool. Right? So it's very easier for us to actually convey our scientific result to the audience. And the second one will be some of those applications like disaster management. Like it happens every day, and people see it, people know it, but people have no idea what is happening on the ground, right? If it's shown in a satellite image, like take a look, it's changed. And I can help you like figure out how many buildings are destroyed. Yeah, that's useful information that they would love to have. And they might not need to know to like all this GIS remote sensing. They just know, oh, it's satellite and it's images. You get some analytics and you can make really fast. People will like it, people use it. So love to seeing it like everyone's using it, but sometimes you still have to say that, okay, this is called geospatial. Do you want to measure in GIS? Yeah, come talk to us. Yes?
I want to come back to the question. Thank you for your presentation, but for the question. Oh, thank you.
So, you're fine.
I'm Jimmy. I'm from Forest Environmental Department. And coming back to the question about people and pixels, I could see your answer about the future that includes basically like the pixel part of the question. But how do you see the role of people in this process?
A good question. Right now, like all example showed is just pixels. There's no really people getting involved. But you can do it multiple ways. So if you're doing decision making or something like that, I mean, right, yeah, it's cool that you extract all the buildings, but so what? How do we prioritize the resources? Where do we get the help in those areas? You certainly need to have human in the loops. So in the future, I mean, I would love to see more like resource integrating human dynamics with those AI rather than solely based on everything on AI, because like I said, when it's automatic, everything is like, sometimes it's nothing. It's not very accurate. So you certainly need to have human to actually to supervise or check some of those results, make sure it makes sense. And don't, as a recommendation, don't rely too much on AI. You still need to have those critical thinking to see what's valuable, what's right, what's wrong. And I think in this new generation, we tend to like, yeah, dump everything into AI and just like use the result. And then, for example, I designed a lab assignment. They finish it, but they don't really thinking why we are doing this. What's the mechanism behind, and how do you make something transferable to other areas? I think those are some of the critical skills that's very important than just, oh, I want to learn how to do Python. But yeah, but the more important is those conceptual stuff like objects and other stuff like transferable to other languages. So usually I tell my students, yeah, don't like forget about Python or R or whatever. It doesn't matter. It's more like you're thinking. R might not be relevant in 10 years. I know like there are new languages coming out. In 10 years, nobody is doing programming. You just AI, okay, write a program and automate this. You don't really need to know. But how do you convert a question into something that the AI can understand? I think there's a whole level. So if you can get to that level, you can get your work done really quickly. So in the future, for example, everyone has an AI assistant. But who gives the base instructions? The one that's going to keep the job. Otherwise, I mean, we all have access to the same resources, but we all have access to the same internet. But why some people can get the problem solved very quickly, and some people have to search internet and page without getting the right answer. So I think that skill is more important than a specific coding skills or specific. It's more like I think it's your ability to learn how to learn. I think that one is more important than concrete like programming, C++. It doesn't matter. I think to me, the graduate education, the most important thing I learned is to learn how to learn by yourself and solve the problem. And all the theory foundation, yeah, it's important, but things change all the time. It might not be relevant, right? So 10 years ago, we still learning some basic, but now you can really learn any programming languages using ChatGPT. Spend a day, you probably can get started pretty easy, step by step by those programs. Just my personal opinion. People have different opinions, so it's totally fine. But that's just my kind of based on this past decades of learning experiences doing development and maintaining some of those open source stuff. Any other question?
All right, I have one more question. As we all kind of, as you mentioned, really that geospatial is pretty much everywhere and everybody has access to it. As far as it being kind of like a major, do you think in the future, because everyone has access to it, that'll kind of just be a requirement course for anybody to just learn? Or do you think it'll still kind of be specialized to where only a few, like people really know it and then some people just kind of know it?
Yeah, I don't think it's a requirement for everyone. Not everyone, right? Everyone will use Google Map, Apple Map, right? They only need to know how to use it, but they don't necessarily need to know like all the theoretical stuff and the background, how it was built and other stuff. So certainly it'll be useful to know, but I don't think going to get into a curriculum, not to mention like high school, elementary school, or even universities, right? In here, how do you convince the whole, every department doing physics or chemistry, like learning GS? Yeah, as long as you know how to use it, that's fine. But if you really want like support the foundation, the development, other stuff, it's good to know the basic, but it's getting more popular, but I don't think it will be like really everyone is doing geospatial. We'd be love to see that, but it's going to take a lot of training, teaching, and so next time if you go like open YouTube without logging into account and you pop like all geospatial video, people, yeah, they will be perfect to see that they're coming. But mostly it was just news and financial and other stuff because more people are interested in, it's more related to what their daily life. Although we use that, but it's for now, for most people, it's just a tool. But it's up to us as educators to teach people how to use that. Teach their kids. The kids go back to the parents, teach them how to use it, and then go back. But for the older generation, I don't think they are going to learn like GIS, geospatial, cloud computing. It's just not their priority. But you can try our best to educate the next generation. So in that way, GIS one day it becomes available to everyone. Then there's no GIS major. It's just like now you need to learn the basic skill, but maybe the next century, I don't know. I'd love to see that. Yeah.
We have time for just one more question.
A lot of your previous research, your PhD and stuff was more on the wetland inundation side, and in recent years, you've been much more on the development side. And I guess, where do you see yourself going? Do you think they'll stay more on the development side, and how do you balance those two interests?
Yeah, good question. So that's something I also struggle. Okay. So as an academia, in the tenure system, you have to publish, you have to get funding, and you just cannot get funding by writing packages. You still need to publish. So I try to balance because I can publish this paper, doing a lot of time and getting a publication out, but eventually it's only a very narrow area. Only people doing really wetland or inundation maybe do your paper, but if I'm developing tools and packages, it gets to the hands of everyone around the globe. Anyone can use it. And I think they bring some indirect benefit because I bring more opportunities. I get more jobs. I get more funding because people know, people trust you. And the reason I can do it is because I already have these packages. And then in your proposal, I can claim that, okay, I already have this. It is already set up as large user base. People want to trust you because you already have the track record of making things accessible. But it's not direct, so it doesn't really contribute to my publication. I still have to do that. I still have to supervise students. I still have to do that. But because I already have tenure, so now I don't have the pressure that I need to publish 2 papers per year. I can just work on the things I like and then writing these tools. But I check on my students, or how do you do something like this? How do you utilize this tool to help your research? So I think the next couple of years at least, I will still focus more on the software development, try to build tools and then make accessible. And then when I'm going up for full tenure, then the last 2 years, probably I need to spend more time like writing those papers. Like, so right now it's more like the breadth. But I need to go deep, people and see what's your area. I can say I'm doing open source development. Yeah, that's like any software engineering can do. How does it relate to geography? What science question are you solving? I said, yeah, I've not done this, but I used to do like weather mapping. So I still have to go there to like that area somehow. But for now, at least I enjoy what I'm doing. I enjoy like people using your stuff and then you build tools that are being used by other people. And I don't really care whether I get full promotion or not. It's not right now my priority. But at one point, if I can do it, then I'll be less active on those packages, less active on social media, just finishing some paper during the summer or something like that, and then get things out. But like I said, I can do it, but it's like, I can show that I'm doing some research, but it's not really like having an impact because not many people are reading your paper. It's very narrow. So trying to balance. And for my students, then they will have to be very in-depth to show their resource area, resource topic. But for me, I like what I'm doing. I just want to do what I'm doing right now. I don't have to listen to my boss like, you need to do this topic, do this. So yeah, I don't care. I enjoy doing this. I'm doing it in my free time. I don't have to worry about publication, funding, and other stuff because I have tenure. That's the benefit that we have like in academia is you don't have a boss. You can choose the topic you like. So I still have this for a couple more years before I have to go up for promotion or full probation. But I might not stay there until I have full probation. I don't know. So right now, just enjoy the moment.
That's a great way to stop.
We have time for one quick question.
Sure, give me 2 seconds. 2 seconds. We'll make it better.
So in connection with your this conversation, so how important is to have the subject knowledge, say you are ecologist, geologist, biologist, compared to having this geospatial technical skills? Like, how do you see that?
Yeah, I think it's important. It's certainly, you need to have some domain knowledge specifically to your area, forestry, urban planning, or whatever. Otherwise, I mean, you can certainly have geospatial, but it's solely focused on the technical side. At the end, right, just similar to the question I asked, like, okay, well, yeah, why? A software engineer can do that. What's the difference between your skills with some software engineer, right? All the Google, for example, think about here. If you're doing simply on technical one, you are never going to be some computer scientist like working at Google doing technical. You see how they build Google Map, Google Earth, right? We all do very cool geospatial stuff, but please tell me who has built a product that by used by billions of people around the globe. It's actually not my geospatial people. It's by pure computer science or engineer. And so if you're doing something really technical, it's fine, but you sometimes have to have something that they don't have. Otherwise, you are just doing a job that a software engineer can do, and they can do way better than you. So why should we hire you? Or hire you because you have some domain knowledge, you have some subject area that you engineer don't have. So even Google, for example, they can build these cool products, they can build Google engine, but the engineer might not understand, oh, what are the near infrared band? Why do we use the NDVI, or why do we use NWI? How do we actually do those? Yeah, you just build the deep learning algorithm, dummy into it, get some result. Yeah, but how do you interpret? How do you make changes, right? So those things, certainly you need some domain knowledge to be able to make it better, more efficient, or you understand the driving factors, right? So you can see, okay, it's changing, the water is moving. Yeah, we only see it's changing, but yeah, what is changing? How it's moving, right? You cannot just solely based on AI to tell you everything. There must be some domain knowledge involved. For example, forest training, deforestation, all kinds of stuff. Yeah, if you have the knowledge in forestry, you know why the technology is changing, how quickly it's changing, why it's changing, how it's going to move like into the future. So those things will be helpful to make you different from pure technical side. But certainly, I think the technique is important because if you have that, you have the domain knowledge, you know how to implement, you know how to research, and then you publish and other stuff. So it'd be nice to have both. But for me, I think I started as a technical person without really a lot of knowledge, and then I learned along the way. So this is why I think usually it's easier for computer scientists to come into GS and then to learn it and then excel because they already have the technical skills and then they can learn the concept quickly. But it's actually challenging for geospatial to get into computer science because the technical skills are much. It's like if you're geospatial police, a bit difficult to be hired by Google and Apple compared to those, right? Because they already trained. So I mean, in general, but it's nice to have mix of those. If you are very strong in technical and you also have the domain knowledge, you don't have to worry about not getting a job. You always be hired because you have all the things that make you self different from the pure software engineer or from pure geospatial like geography that without the technical skills. So it's nice to have a mix of like at the end of the day, ask yourself why should the employer hire you? What makes you different? Can you come up with some keywords that identify yourself? If you have some identity, you make yourself different from other people, you're more than likely to be hired. Otherwise, just another software engineer, another GIS analyst, right? You can be easily replaced. But if you become something that people rely on you, yeah, you always have a job if people rely on you. Yeah, that's just my personal opinion. Thank you very much. Perfect. Thank you.
Thank you all. Have a good afternoon, and remember, there's a happy hour.